There are two types of motion that a planet can have. The first is rotation, which is spinning, and the second is revolution, which is orbiting around something else. The first one we're going to consider is rotation. Here is Dorothy, and she is rotating. But there is a problem. Dorothy is rotating clockwise.
Remember the right-hand rule.
The right-hand rule states that all planets orbit and rotate in the same direction, and you can remember that direction as counterclockwise, or if you have your right hand, it's the way that your fingers move when you close your hand, if your thumb is the North Pole. Now Dorothy is rotating in the correct counterclockwise direction. Each planet has a unique way of rotating. They all follow the right-hand rule. However, north is not always pointed directly up in relation to the plane of its orbit. Earth, for example, is tilted 23.5 degrees on its axis. Venus is tilted 177 degrees on its axis. So from the perspective of the Earth, the North Pole on Venus is actually pointed down. So to us, it actually looks like it's rotating backwards. And the planet Uranus is tilted 98 degrees on its axis, and so it looks like it's rotating sideways. Now we think that most of the reasons for these tilts are because of collisions in space that knocked these planets off of their up and down axis. The other type of movement that a planet can have is revolution, which is when a planet goes around the sun.
I'm the sun and this is the earth.
Here we see Dorothy as the sun with the earth revolving around her, and of course the string that she's holding on to would be like the force of gravity. The scientist who really figured out the nature of how planets move in space was Johannes Kepler, and he came up with 3 laws to describe how planets move. The first states that the orbits of planets are ellipses with the sun at one focus. The second is that a planet moves faster in its orbit when it's closest to the sun and slower when it is further from the sun. And third, planets with large orbits take longer to orbit the sun than planets with small orbits. The first thing to know about planets is that they each have their own unique shape of orbit. And some planets have a very circular orbit around the sun, and some planets have a very elliptical orbit around the sun. And when we say an ellipse, this is what we mean. An ellipse is like a circle that has 2 centers. And the center, if you're talking about one, it's called a focus. And if you have 2 focuses, the appropriate term is 2 foci. And the way we would describe how oval an ellipse is called eccentricity. So a circle has an eccentricity of 0, and a straight line has an eccentricity of 1. And what Kepler figured out is that the sun is at one focus of a planet's orbit. And he also figured out that a planet moves fastest when it's closer to the sun, and it moves slower when it's furthest from the sun. And one of the things we're going to have to do in class is learning how to draw an ellipse. So this diagram is a good reminder of how to do that. Each of those thumbtacks would represent a focus, and then the green line is a string, and so if you keep your pencil in the string, you wind up making an ellipse. And the wider apart you put those foci, then the more eccentric the circle would be. The way that you can calculate eccentricity is the distance between the foci, and you can see that red line there would be the distance that you would measure between those 2 points, and the length of the major axis. And the major axis is the widest part of that ellipse. So in this you can see that blue line is the length of the major axis. And lastly, I just wanted to remind you to look at the solar system data that's on page 15 of your Earth Science reference table. It's a pretty easy data table to read, but we will be having some questions from this, and make sure that if there's any part of this that you're unsure how to read it, that you ask in class.